We are going to practice using the trace determinant plane in order to classify the 0-0 equilibrium system, solution of a linear system. So we have four linear systems represented here in matrix vector form, and I've sketched quickly the trace determinant plane with classifications, and we'll run through this process and see that we can use this to classify things pretty quickly. So what we need for the trace determinant plane is the trace, which is the sum of the diagonal elements, so 3 plus 1 is 4, and we need the determinant. The determinant in this case is 3 times 1 minus 1 times negative 1, so the determinant is also 4 in this case. So determinant being positive means we're on this side of the trace determinant plane. We don't have a saddle. Tau being positive means we're on this side of the delta axis. So we're on the unstable side of things. We're in this quadrant here where things are unstable. And the question is, are we an unstable spiral or an unstable node? And we answer that question by looking at whether we're above or below this parabola. Tau squared equals 4 delta. So we look at tau squared minus 4 delta. And in this case, tau squared is 16 and 4 delta is 16. So tau squared minus 4 delta is 0. That means we're right on this line, which makes us an unstable node. So A here, I guess I'll write them down here, is an unstable node. So we have an unstable node for A. Moving on to B, again, we just need tau. The sum of these two is 0. So tau is 0, that puts us on the tau equals 0 axis here, the delta axis. And delta, the determinant, looks like minus 4 minus a negative 6. So minus 4 minus negative 6 is 2. So we are on this axis above the tau axis. So delta is positive, so it's not a saddle. We're somewhere in here. That makes it a center. And remember, a center is a stable equilibrium. Those are just pure oscillations in x and y. For C, we have tau equals 5 and delta equals 6 minus 12. So negative 6. Delta is negative. If delta is negative, we're down on this side of the tau axis, and that means we have a saddle, which is unstable. So we will have solutions in x and y that go to plus or minus infinity for most sets of initial conditions. And finally, D, I'm mixing my uppercase and lowercase letters. It's just a mess, but we're getting it done pretty quickly here. Tau is negative 4 plus 3, so that's negative 1. And delta is negative 12 minus a negative 15. That looks like 3. So delta is positive, we're on this side. Tau is negative, this side, we're on the stable side. We're in the stable quadrant of things. And again, the question is, are we a stable spiral or a stable node? And the answer is we have to look at tau squared minus 4 delta. So tau is negative 1, tau squared is 1, minus 4 times delta. Tau squared minus 4 delta is negative. If tau squared minus 4 delta is negative, that means the delta bit is bigger than the tau squared bit. That means we're up in delta. We're above the parabola, and that means we have a stable spiral. So we have the phase portrait looks like this, but the solutions in x and y are decaying oscillations that equilibrate or asymptotically approach 0. So those are 4 quick classifications. You see how quickly we can do these with the trace determinant plane. It takes a little bit of getting used to, especially when you have to do the tau squared minus 4 delta comparison. It's super quick if you have a saddle. Delta is negative, you got a saddle, that's really quick. But they're all pretty quick.